Alright, at this moment you might be thinking that we're done with all the boundary analysis, we should move on to all the quarter nodes. But if you take a closer look, we still have two more boundaries that we need to analyze, and those are the interior insulations. So let's first take a look at the interior insulation horizontal. So these are the two green dots right here. So if we draw a control volume around it, and then we have our east face, west face, north face, and south face, and also our TP, TE, TW, TN, and TS. In this case, it's very similar to the bottom surfaces where TS doesn't exist. You might be thinking, hey, there are some nodes down here. Why aren't we considering them? Well, it's because outside these two insulation in this area, remember that's where the ice cream is located. So all the temperature distribution should be 0, and technically they're outside our analysis domain as well. So that's why we consider these just non-existing. So now if we look at our governing equation and apply it to the specific node, we'll have our south flux goes to 0, right? Because there is an insulation boundary condition applied. And now if we rewrite this into our coefficients form without having TS, then this is what we have. So we have this expression in terms of TP, TW, TE, and TN. Similarly, if we look at the insulation, now let's take a look at the interior vertical insulation. And these two green dots here represent the vertical insulation nodes. So if we draw a control volume around it, and we have our east face, west face, north face, and also the south face, and we also have our TP, TE, TW, TN, and TS. And we look at our boundary condition, the TW doesn't exist because it's insulated, so there's no node technically to the left or to the west of it. So now if we apply this boundary condition to this specific node, we're going to eliminate the second term completely because that's the heat flux coming from the west face. So now we're going to rearrange this into our nice looking coefficient form, and ignoring the TW term because there's no TW, and this is what we get in terms of TP, TE, TS, and TN.